Let k be 2008 to the second power plus 2 to the 2008th power. This is a huge number. This is more than the number of atoms in the universe. Okay, what is the unit digit of this? You know, if you look at it, oh, it's symmetric. K seems to be 2008. No, no, no. You are supposed to compute the whole thing, which is a huge, huge number. Then you are going to square it, and as if that's not bad enough, you are going to raise that huge number to the 2. Okay, how do we do that? The answer is we don't do that. What they want to know is not the answer to this. They wanted to know the unit digit of it. Okay, how do we do this? Let's find the unit digit of k first to see if it shines any light on our reasoning here. Okay, do you know the unit digit of this? Let's see, 2008 to the second power. Okay, you could do it, but we are wondering about the unit digit. So last digit is 4 because 8 times 8 is 64, so ends in 4. So let's leave at that. And then what about this? 2 to the 2008. Whoa, how do we do this? Whenever you're facing with something daunting like this, you got to get a pattern out of this. So, you know, you would tell yourself, I would never reach 2008 within my lifetime if I start doing this. I agree. Still, you got to start so that you can see the pattern, not to finish the job. So this is 2 here. 2 to the second is 4. 2 to the third is 8. No pattern yet. 2 to the fourth is 16. No pattern. 2 to the fifth is 32. Pattern? 2, 32? Yes, because we only care about the last digit. Finally, the last digit repeated. But how do you know if this was an accident or this is a repeat of the pattern? So you do one more. Oh, ends in 4 and 4. Does it guarantee that you enter the repetition of pattern, or you just got lucky twice in a row? You know, if you start asking like that, you would never be sure, because you may got lucky 2,000 times in a row, and 2,000 first time would be different. So you have to dig a little bit deeper into it and confirm or validate, verify where these numbers are coming from. How did you get this 4? Multiplying by 2. How did you get this 8? Multiplying this by 2. Now, how did this 4 come about? Multiplying this by 2. And if I multiply this by 2, sure, I would get 8. So the mechanism for generating these are the same. This is not like, the random number sequence generator that happened to produce the same thing. So you see, they match. So therefore, this is the way to do it, and the numbers will repeat every 4 times. So if the exponent is evenly divisible, it divides without remainder by 4. That is, if the exponent is modulus 4, 0, that is, you get 0 and you do modulus 4, then the end digit will be 6. Okay, do we have that case? If I divide this by 4, what's the remainder? Let's find out. I'm sure you see it in one shot. I do 2. But I do it anyway. Okay, you know what I meant, right? I meant to carry 8 here, then put there an 8 and 0 here. No remainder. So this will end in no remainder case, that is, ends in 6. Okay, now you could do this a lot faster, of course. I'm talking and showing, so that's why it's going so slowly. So here, I'm adding these two because they told me to add. What do I get? 0. Of course, I get a huge number followed by 0. That's great. So k ends in 0. We don't know what k is, but we know it ends in 0. So let's see if we can find out what this becomes. So k squared is something that ends in 0 squared. So it will end in 0, 0. That's great. What about 2 to the k? 2 to the number that ends in 0? Okay, not so sure. But we just did this 2 to the k business. It is just a matter of going and seeing what the remainder would be when you divide it by 4. So suddenly I want to divide this huge number by 4. Then I find out I don't even know what this number is. So how can I divide by 4? So you get a little more clever and say, well, if this is multiple of 4, and this is multiple of 4, and this will be multiple of 4. If there aren't, then from their remainders, I can figure out their sum's remainder. Okay, let me show you what I mean. If a number is multiple of 4, if another number is multiple of 4, if you add them, the sum is multiple of 4. As simple as that. So let's examine each one individually. 2008, is this a multiple of 4? You're looking at it. Yes, it is. What if I square it? It is a very multiple of 4. Very good. So this is a multiple of 4, this number. What about 2 to the 2008? Is this multiple of 4? How do we do that? This pattern would not help you because this pattern is all about checking the last digit. It's not checking if it's multiple of 4. I'm sure many of you just saw the pattern right away, saw the answer right away. But for those who didn't, let me show you this way. Is this multiple of 4? To do that, now you just try to make it 4. How about 2 to the second power? That is 4, isn't it? It's that. So it's a 4 to the 1004. So this number turns out to be extremely multiple of 4. Very multiple of 4. So remember, this was doubly multiple of 4. And this is extremely multiple of 4. When you add them, k is multiple of 4. So we have 2 to the multiple of 4. You know what happens? It ends in 6. Okay. Now, they wanted us to add them. Okay, we are going to get a huge number, but we are going to check the unit digit. So 0 plus 6 is 6. So it ends in 6. So we got away without actually doing the computation in this horrendously huge, the numbers where the numbers are so horrendously big. So once again, this becomes a pattern recognition, pattern detection problem. To do that, I have to emphasize one more time, staring at it would not help you. You got to start writing as if you're dumb and as if you're about to do this impossible task, as if you are about to dedicate your life to find 2008. And in doing so, in a way, it's a fake move. You start doing as if you're going to do it. Then it reveals itself. It tells you, I'm made of this. Then you say, aha, gotcha. Then you quickly dump the whole project and get the essence out of it, answer the question, and move on to the next one.